So let's take a look at an implied problem here, example 2. If blood sugars are normally distributed, so that means that we can use z-values, the normal distribution with them, with a mean of 105 and a standard deviation of 12, find the probability that a randomly selected person will have a level that is greater than 110, between 90 and 120, less than 95. So all of these are going to be normal CDF problems because it's a normally distributed data. So our mean is 105. So mu is 105. And standard deviation is 12. So sigma is 12. So, and we'll use normal CDF again. You specify the lower bound, the upper bound, and then on the end, if you're not using mean 0, standard deviation 1, you'll have to enter those in. So, what is the probability that a randomly selected person has a level greater than 110? So you can write this in symbols as probability that X is greater than 110. So I used X instead of Z because our mean is not 0, our standard deviation is not 1. This is a normal distribution, but we're not converting to the standard normal. So this will be normal CDF. And our lower cutoff, well, we're greater than 110. So if we sketched our distribution down here, mean is 105 here in the middle, greater than 110. So that would be to the, to the 110. To the right of 110 would be this area over here. So our left cutoff is 110, our right cutoff will be 1000. So 110 to 1000. Mean 105 and standard deviation 12. Okay, let's enter that in. So I want second variables. Oops, turn on. Let's clear out. Second variables. Normal CDF is option 2. Our lower is 110. Our upper is 1000. And then we have to change our mean and standard deviation, update our mean to 105 and our standard deviation to 12. So 0.3385. So, and that's what this area is 0.3385. How about what is the probability that a randomly selected person has a value between 90 and 120? So we could write that as probability 90 less than X less than 120. So this will be normal CDF. And our lower cutoff will be 90. Our upper cutoff is 120. Mean is 105. And standard deviation is 12. So in picture here, we're going from 90 down here up to 120. So it's this area in here. So let's go ahead and key that in. So this will be second variables, option 2. Our lower cutoff is 90. Enter, upper cutoff 120. And then mean and standard deviation stay the same. So 0.7887. So that's what this area is. 78, almost 79% of the area. What's the probability that a person has a level less than 95? So that's the probability that x is less than 95. So less than 95. Let's say that this value instead of 90 was 95. So less than 95 to the left. So our left cutoff, we're going to use some big negative number like negative 1,000. So normal CDF. And negative 1,000s our left cutoff. 95 our right cutoff. 105 our mean. And 12 our standard deviation. Key that in with me. See what you get. So negative 1,000 up to 95. 0.2023. Okay, and that's also this area. So we did an above, a greater than, we did a between, and we did a less than or lower than. Now, one thing I'll note here with normal CDF and with areas underneath the normal distribution, it doesn't matter whether you've got less than or less than equal, those probabilities are the same. So 0.2023 is also the probability that x is less than or equal to 95. Because if you just include the line at 95, you haven't added any more area in there. And the same thing up here. We could have less than equal, and greater than equal, and those wouldn't change the way we do the problem. So whether it's a strict inequality or not a strict inequality, you do things the same way. So, okay, try Canvas Homework 6.3, problems 2 through 5.